This is Perenev's magnetic motor. You'll notice that the rotor and stators are constructed of a plastic called tafenol. The frame is of tubular aluminium. The main bearings in the unit are high-speed self-centering bearings. This particular motor develops some 9 kilowatts of power. This unit is with the manual speed control, which can be seen now. The later versions have electronic speed control. Going in now towards the rotor, you'll notice the magnets and the plastic stay pins. These are to keep the magnets in place. In front of the magnet, you'll notice a half-moon cutout. That is for the new shielding to go in, which we're currently waiting for. There are 3 main rotors, and they're all offset at 20-degree angle to each other. This will allow the motor to run. This is the motor now starting up. You'll notice that the stators are going in toward the center rotor. As the stators get closer to the rotor, so the motor will start to turn. The closer the stators get, the more power is delivered to the main rotor and the speed will increase. We will be taking this motor up to approximately 3,500 RPM, at which point I will open the stators to slow the motor down. The motor operates at high RPM. Normally its duty cycle is about 6,500 RPM. Opening the motor now. This will now begin the slowing down process. The later units are constructed in a modular type frame. This will allow easy removal of the motor unit from the main alternator assembly for servicing, maintenance, and so on. I will be picking up the camera shortly and moving it around the motor. Now picking up the camera. This is the drive side of the motor. The long shaft sticking out is the shaft which will be coupled to the alternator either via chain or via multi-V belt. You'll notice the rotor is now coming to a standstill and seesawing on the magnetic fields. This is the bismuth shield that we use to shield the field of the magnet, or to change the shape of the field of the magnet, if you like. Bismuth we found unsuccessful for this application and moved on to better quality diametric material. This is the neoboron magnet, measuring some 25 millimeter by 22 millimeter, producing some 19,000 gauss. Later units are using 35 millimeter magnets, producing some 320,000 gauss. This is the magnet and its shields next to each other. You'll notice that the shield is slightly longer than the magnet. This allows for better field control. This is the early rotor. This is rotor 1 of Mark 1. We had a problem with the aluminium which created an EMF current when the magnetic fields were induced. It caused a lot of difficulty with the cutting of this motor, as you can see by the angles, and you'll also notice the magnetic stay pins at the top of your screen now. In the center, on the outsides of the rotor, you'll notice slots. These slots allow us to remove magnets in the case of servicing For example, if a magnet is cracked or broken, etc. Now easy removal of the magnet. Going toward the center of the rotor, you'll notice holes drilled in. This particular motor has 12 holes. These are 20-degree offsets to allow the rotors to be offset 20 degrees from each other, allowing the